find the Norton's equivalent circuit of this given circuit. So when we see this circuit, we are going to use Norton's theorem. So first step is, here is terminal A and B. Then we are going to short circuit this terminal A and B and put Isc. So now the circuit becomes like this. This is the terminal A and B. We should circuit it and put the current Isc. So now we are going to find the current flowing inside this circuit before the Isc. So when we look at this resistor to find the equivalent resistor so that we can obtain the current using Ohm's law, these 4 and these 4 are in series and parallel to 8. That means we have 4 plus 4 times 8 all over 4 plus 8. 4 and this 4 in parallel to this 8. So that is how we obtain this. Then this is equal to 4 plus 4 times 8 is plus 32 all over 12, which is equal to 6.667 ohms. So now we are going to find the current. We know I is equal to V all over R, which is equal to, our voltage is 20. 20 all over the R is R equivalent 6.667, which is equal to 3 ampere. So now we are going to find the Isc. To find Isc, we are going to use current divider. This 3 ampere is the current flowing from this 4 ohms resistor. So now this current will be divided into 2. One will be here and the other will be here when divided. So now we are going to use current divider, which says Isc will be equal to IR1 all over R1 plus R2, which is equal to, the current is 3 ampere times R1, 4 all over 4 plus 8, which is equal to 3 times 4 is 12. All over 4 plus 8 is 12. That means we have 1 ampere. That is Isc. So now after finding Isc, we are going to find the R Nortons. To find the R Nortons, so now to obtain the R Nortons, we are going to short circuit this voltage. This is where we have short circuited the voltage. So when looking indirectly to the circuit, we can see that this 4 ohms resistor is in parallel to this 4 ohms resistor and in series with this 8 ohms resistor. That means we have 4 times 4 all over 4 plus 4 and plus 8, which is equal to 10 ohms resistor. So now we can redraw the circuit again. This will be the equivalent Norton circuit. And it is drawn in parallel to the current. This is our Norton's current, that is Isc, and we obtain it as 1 ampere. And this is the resistor, equivalent resistor, and this is the last resistor that we have in the circuit. So now to obtain the Norton's equivalent resistance, the last circuit will be this 10 and these 10 are now in parallel. We have 10 times 10 all over 10 plus 10, which will give us 10 times 10, 100, all over 10 plus 10, 20, which is equal to 5 ohms. So now the equivalent Norton circuit will be the current parallel to the R Nortons. The R Nortons is 5 ohms, and the equivalent, the current ISC is 1 ampere. So this is the Norton's equivalent circuit.